Okay, in this video, we're going to look at Lesson 3, Part 1, where Part 1 looks at the association between two variables, but in only these two situations. We'll look to see what do we do if one of our variables is categorical and the other is numerical, and then we'll look to see what do we do if both variables are categorical. So far in the course, we've only been looking at one variable at a time, and we want to think about looking at two variables at a time and seeing if they are associated. Okay, so some examples we might ask, is there an association between a person's gender and their height? Okay, so two separate variables, we want to see if they're related. Notice that gender is a categorical variable and height is numeric or quantitative. We might want to know if there's a relationship between a college degree a person receives and their starting salary. So again, this might be categorical, and then their starting salary is numeric. Or we might ask, is there an association between how many credits you're taking this semester and how many hours you plan on working at a job? In this case, we have two quantitative variables. We could also have another situation. Is there any association between a person's gender and their major? There we would have two categorical variables. So depending on the situation, we're going to have different methods to determine association. Before we get to that, often when we have two variables, there's a clear choice for what we call the explanatory variable and a clear choice for the response variable. The explanatory variable is the independent variable. So if we ask, is there association between gender and height, then height should be the response variable. Height should depend on a person's gender in general. If we ask, is there a relationship between degree and starting salary, we're likely trying to show that salary depends on your major or your degree. Is there any association between how many credits you're taking and how many hours you're working? And sometimes there's not a clear choice, and that's okay. So we don't have to always have an explanatory and a response variable. Okay, so what we want to do in this video and in part 2 of lesson 1 is to think about when we have two variables, what are appropriate graphs and numbers to look at association with. So in this video, part 1, we're only looking at these two situations. Okay, we're going to start off by looking, what do we do if one variable is quantitative and the other is categorical? And then the second part of this video, we'll look at what do we do if both variables are categorical. Okay, so there's certain graphs that are appropriate in each situation. There's certain numeric statistics that are appropriate. We'll do this part in the next video, lesson 3, part 2. In mind, when you have a quantitative and a categorical variable, use side-by-side box plots to see graphically if there's association, compare means or medians numerically. If both graphs or variables are categorical, we can look at making a side-by-side bar chart and comparing relevant proportions. Okay, so let's look at the first instance when one variable is quantitative and the other is categorical. For instance, is there any association between a person's gender and their height? So this slide we can do graphically is to use a graph you've already seen, and that's a box plot, and we can look to see is there any association. So we're going to use something called a side-by-side box plot here. All we're doing is creating a box plot for the male heights and the female heights and looking at them. Okay, so I can see here that the median height for men is about 72, whereas for women it's 65. So there's quite a difference between the heights for men and for women. And I would say yes, their height and gender do seem to be associated. There's a clear difference in this distribution versus this one. So side-by-side box plots is a standard graph we use when we have one categorical variable and one quantitative variable. If we had 4 groups, we would have a separate box plot for each of the 4 groups. You want to keep, here's another example. This was looking at gender and how many siblings people have. And in this situation, I really wouldn't say there's much of a difference. We had a couple of outliers for the females, but there's not really a discernible difference between the distributions for males and females. The medians are pretty close, quartiles are pretty close. Okay, numerically what we can do is we can separate out the data, and for females we could get the mean height, and then for males we could get the mean height. Standard deviation and median if we like as well. So we can see here that on average men were about 7 inches taller than women. But for the sibling data, we don't see much of a difference between the average siblings for females and males. Okay, and again, I'll show you how to do all of this in Minitab in the next video. Okay, so what do we do if we have two categorical variables? Like maybe we want to know, is there association between a person's gender and what meal they would order at a wedding? Okay, so here's some data using Minitab. Here's the female data and the male data. And the menu options were chicken, prime rib, salmon, and vegetable lasagna. And so using Minitab, we can get the percentages of all the females who said yes for chicken, prime rib, salmon, and lasagna. So about 38% of all women said chicken, whereas only 17% of men chose chicken. For the prime rib, a lot more men chose prime rib than women. Salmon was pretty even, and hardly any males chose the vegetarian option. So we want to know, is there any association? And that means are males more likely to pick one of these menu options than women? And it's hard to tell with just the raw count. That's why we do percentages. And it really does look like there is some association. Many more women than men chose chicken, but the opposite is true for prime rib. Graphically, we can use a side-by-side bar chart to investigate. So this graph is the female data, this graph is the male data, and we can really see a difference in this distribution. This distribution is not the same as this, or not approximately the same. So if the distributions are different, then we're going to say there is association between the variables. Okay, what people order seems to be influenced by their gender. Here's another example. I wanted to look to see if there is association between how one identifies in terms of male or female, and then their class year. Okay. And we shouldn't expect any association here, and I think this data supports that. The distribution of class year for females is roughly the same for males. These two graphs aren't discernibly different, so it doesn't look like gender and class year are associated. Okay, so just